My name is Ehsan Fazel, systems architect, joined by Greg Leonard, who's a technical solutions architect with Cisco, and we have got around about 30 minutes of presentation for you. Walk through some of the slides and talk about the use cases, etc. There's a chat window, I believe. If you got any questions, feel free to post them there. We try to answer them as we go through, or if more time left and there are more questions to be answered, we can take them at the end as well. So my engagement with SMLL was very much in coming up with solution for the requirements that has been set out for the Smart Mobility Living Lab that allows test and validation of connected and autonomous vehicle in real world environment. And the intention was to build an infrastructure that not just suits the needs of today, but also what the future would actually look like. Variety of technology has been used in there, and very fundamental requirements was connectivity, to no surprise, and given it's for operational environment and has to be trustworthy. When it comes into connectivity, obviously things looks quite simple to start with, but once you dig into the very details, you all of a sudden realize that actually you just got dark fiber optic to deal with. Sometimes you have no connectivity, you got to rely on 4G. Some places you got untrusted network, and all sorts of different environment that you would face in a real world environment. All of a sudden an OT, it just starts to emerge, and we had to move offices multiple times. We had to have that flexibility. We got remote users that spread across the globe. If I'm honest, they try to help us building some of the solution that requires additional support. And all of that requires to be available as and when is required. And there's some data, sensitive data, to be protected because of the GDPR and all the rest of the regulations around it. So we had to ensure the services are available as and when is required, and also been secured. Last but not least, which is the interesting, was to build an open architecture for the future, right? It's something that actually allows us to take advantage of the digitization, being able to build a platform not just to operate on its own silos, but also being able to integrate with others, bring innovations to build solutions on top of it, and make it as a platform that everyone can benefit from it. It's worthwhile mentioning that actually this project is sponsored by Country Digitization Acceleration within Cisco, which is part of the corporate social responsibility that we're helping accelerating the digitization agenda across countries in order to drive efficiency, improve productivity, improving skills of people, etc. So there are further details there. I encourage everyone just to go and take a look in there. Also, we do have a research arm, which is called cisco.research.com. There are a great deal of information out there that tells you what are the things we're looking to deploy and evolve over time. So let's look into the transportation landscape. It's worthwhile just mentioning that, reiterating, in fact, logistic is not just one way or the other, can operate independently. In fact, same as data sharing, they need to be able to share resources, needs to be able to effectively communicate with one another in order to kind of the industry can operate all together. And the reason for why I mentioned that, you're thinking about the sea freight, you're talking about the rails, you're talking about the aviations, roads, and there are multiple users of them. There are multiple business models around them. And really they become effective when you actually have the capability to be able to share information between all of that. And that was kind of a very fundamental principle that we used within SMLL to build a test bed, to be able to integrate with others. Think about the roads themselves. There are various road users. There are vehicles, there are public transport, you name it, vulnerable road users, etc. And we had to cater the requirements for all of that through digitization. And when you start to think about digitizing a specific specific event within the transportation sector, all of a sudden you realize you open up huge amounts of opportunities in order to drive efficiency through improving the journey times, reducing the cost, improving user satisfaction, etc. And the cost of digitization can easily be paid off by the new business model or the efficiencies that you're going to drive on the back of it. But we know getting there isn't easy. If you think about the very fundamental, the likes of asset tracking, the likes of how you actually scale out your infrastructure, numbers suggest that 55% of the organization do not have an accurate inventory, let alone all the rest of the issues that will come along with it. But we know the number of connected devices, no doubt, the only direction it goes, they're just growing and growing and growing, right? And if you're not having the right strategy in place in order to be able to cater for those requirements and the growth, obviously, that simply isn't going to cut it out. We therefore needs to come up with solution. We're looking into how IT can enable driving OT, how they can build partnership with one another in order to achieve the digitization and being able to take advantage of the whole technology that has to offer us. Let's look into a few examples, right? How IT enables OT. If you think about it from the vehicle perspective, you can do then predictive maintenance, you can do advanced vehicle diagnosis, usage-based insurance, which is a new business model by its own, telematic and fleet. Depending on which industry you are in, then all of a sudden you realize there are always opportunity for you to exploit in order to achieve your goals or drive new efficiencies. The focus on SMLL, though, because it's kind of very much focused on autonomous vehicle, doesn't mean that it does not include other technologies, but our focus was very much on the public safety, such that we can drive a level 5 of autonomy of vehicle within the horizon. So these are the baby steps that we're taking, but fundamentally we thought it's very pertinent to focus on the public safety element of this.
Hey, Isan.
Yeah.
Real quick, we've got an interesting question here from Asma in the Q&A, and she's asking, what are the vehicle to pedestrian models you have implemented to include other road users? I think that's coming up, but I just wanted to highlight that.
Sure. We haven't implemented just yet, but these are in the future phases. There are methods that we can use, BLE, Bluetooth, for example, technology, or Wi-Fi notification. Similar technologies have been deployed elsewhere. We're looking to do that. Obviously, there are implications on that. Yeah.
Yep. Thanks.
No worries. Anything else, or?
None yet. Please carry on.
Sure. Thank you. So let's look into what have we deployed actually. We instrumented around about 24 kilometers of the road using CCTV cameras, meteorological sensors. There are pop-up infrastructure to do a precise measurement for specific use cases. There are connected traffic light, 5G capable core network, which is on the horizon to deploy a 5G network along with that. If you think about it, the landscape, when it comes into the cybersecurity, all of a sudden changes. When you think about securing an office spaces from cyber perspective, you do have some level of trust in terms of if adversaries can get physical access or not, versus on the roadways, the story is slightly different, right? The cabinets are out in the street, and you may be thinking, well, I'm going to lock it and no one can access it, but the truth of the matter is that people can break into the cabinets. If that happens, then we may get an alert, but by the time we get there, probably is too late, right, to action it, right? Or the damage could have happened, right? So we had to come up with the different strategies and ideas in order to secure the environment, right? So our first and foremost, it was based on zero trust. We're assuming the worst can happen at the access layer. We then thought about what if you have visibility to the asset that you're trying to access to the environment. Now things getting a little bit more interesting because now identity becomes a topic. We're not actually stopping there. We're also looking into if a device managed to authenticate itself, get into our environment, then what is it going to do? And we're not saying it's IT, OT. Now all of a sudden, well, actually, I mentioned they're all integrated as one part. How can we maintain the cybersecurity aspect of it? What we've done, fundamentally, we turn every single touch point on the network into a sensor, right? All of a sudden, we realize actually we're not dealing with just a network that does basic plumbing, but also it generates data for us. And that data obviously talks about which device is talking to where and how, what protocol does it use, all the telemetry associated with it, and that turns into a giant amount of data. Then, then also, which is the next step, which I'm going to come into that, it kind of give us some interesting information that will come on to the next stage. But just hold this thoughts. You got lots of communication information about the files that get into our environment. As CCTV attaches to the network, it does have specific behavior or expected behavior off of a CCTV camera or a LiDAR or a radar or other devices that are there, right? The other thing was we thought about shrinking the zone of trust, which means we provide segmentation and microsegmentation such that we can provide the least amount of privilege that every device is required in order to be able to perform its function. But we're not stopping there. We know things can change. Identity can potentially be cloned. We're not rule this out, but we need to come up with a kind of automation in order to first to action all of that, provide that automatic segmentation, provide automatic kind of micro segmentation, and also the containment, which is an interesting part. So if a device turns to be not what it meant to be or behaving the way it is not meant to behave, then we have an automated process in order to contain the threat from that very specific device, right? And then we can let the administrator to look into, investigate, and see what has happened in the past, whether that's deemed appropriate to let that isolation to kind of being released or just investigated further. I mentioned about collecting lots of data from all the devices. Now, what is we going to do with that, right? Cisco has got a research arm composed of around about 300 researchers globally, which 100 of them are online at the given time. They are mathematicians, cybersecurity specialists, the organization called Talos, which I'll have a reference to that. And they look into internet. They're actually blocking around about 19 billion threats per day. They are investigating 600 billion emails per day, and they are examining 1.5 million malware every single day, right? So we know a lot about what's going on, what looks good, what does not look so good, or what is actually unknown, which is the area of our interest. So if something is known to be good, known to be bad, they could be action quite straightforward. Whilst that research arm organization allows us to understand the unknown and give us recommendation and take an actionable recommendation in order to deal with those anomalies or potential anomalies. And that actually is not possible unless you got an end-to-end integrated system that can work together in order to secure your environment, right? You're thinking about it as a safe, you lock it, you have assurance that your assets are safe. So that was the approach that we took into the cybersecurity. And I'm just going to pause here before I go to the next stage in case there are any questions I need to answer.
There is a question, however, I think it relates to your roadside architecture, which is, I think, coming up next. So it might be good to maybe dive into that one, Isan, real quick. That's the only question that we've got, but the question is around a very specific question around traffic lights supporting a particular standard ITS G5.
Yeah, sure, absolutely. We'll come on to that. Right. I mentioned we had to build an architecture for the future, and Cisco is not shortage of having validated design. We've been blessed with that. So rather than reinventing the wheel, we thought, what if we look into what has happened elsewhere and come up with a solution that we know it works. The time to deploy is shortened. It's being de-risked because we know it worked elsewhere, and the same kind of a concept has been deployed the same places. So now we're talking about the vehicle themselves as to how we're going to turn them into the sensor, right? We do have test vehicle. They are generating data on in terms of the real-time location, the speed, the roll, the pitch, the brake pressure, steering angle, you name it. And these are the array of attributes been collected on a 100 hertz, I believe, and then or others on a different frequency, if you like. And that kind of give us great deal of information in order to be able to turn those into an insight such that we can generate data that is useful to the other drivers. So, for example, if a driver slammed the brake, then you get a red light on the back, obviously, but not 3-4 cars behind it wouldn't be able to see that. But that we turn those data, and there's a technology called DSRC. I'm glad the question similar to that has been asked. We deployed actually DSRC, which is ETSI-based standard. More widely adopted in North America and Europe, and in the UK a few trials has happened as well, but I'm not aware of a specific actual live deployment, but within the SML we're about to go live on that. But we're in the process of actually start sharing information from the vehicle to the infrastructure. So as from the infrastructure to the vehicle, anything like speed advisor, which I'll come on to that, but about the things a driver should really care about. Anything in case the road is slippery, maybe the pitch and angle of the vehicle is turning, or high acceleration, that's indicative of a slippery road, and therefore advisory messages should be sent out via variable signage. Variable signage actually isn't in scope, but this is something we can exploit. But we're looking into HMI in order to deploy it in a smaller scale, if you like.
So, Isan, we've got a couple of questions coming in just now, very relevant to the roadside architecture piece, and you kind of mentioned DSRC a bit, but we have a couple of questions here I'd like to bring up. One was what Saket has just asked, which was, how is Cisco tackling the DSRC versus the CV2X interoperability, i.e. the agility, is one question, and then
Sure.
another one.
No, it's a very good question. It's kind of based on the latest information I have. Regulators are taking an approach of to say we actually care about the functionality versus the actual implementation, and we kind of took a neutral approach. You can use even 4G LTE today to communicate those data, but we know that's not reliable so much all the places. We deployed the DSRC ETSI standard. We're looking for ITSG 5 as well at some point in the future, but at this stage we had to focus on getting things off the ground, but certainly it's on the radar to trial at some point when it becomes available.
Okay, then also kind of related to that, Asma's got another question in here. It says, have you implemented vehicle-to-vehicle V2V, and which applications have been deployed?
We haven't deployed V2V just yet, but in fact, it's not on the horizon just yet, but I may be wrong, but we can come on to that later. In fact, this is one of the things we can definitely look into.
Okay, one more question, and then we'll let you carry on here, Isan. It's actually going back a little bit to the cybersecurity one. Saket was asking, what's the role of UK SMLL, or how does the facilities at SMLL help in defining future cybersecurity regulations and feeding them into CAM 2030 roadmap? That's the first part of the question. Any comment on that?
I don't have specific comment. Obviously, it's a test bed, so the intention was demonstrating what good looks like. I suppose that would fall into the NCSC, National Cybersecurity, that they are going to define the regulation. We're kind of industry side, but we're not part of the regulatory. We make regulatories aware of what we do, but obviously, end of the day, that's down to them what to decide in terms of how to deploy it. How
Okay,
to
thanks. And there's a part two to the question that Saket has here, and he says protecting CNIs is critical. So how is Cisco trying to address this, as more than 200 cameras are being used across the test bed, and so are other assets?
Yeah, it's kind of a hard to answer for me. I can speak on, I cannot share a lot, but obviously Cisco has got a role on CNI, to protection of CNI as a whole. But I defer to answer any further than that. But the Talos, I would suggest everyone interested go to the talosintelligence.com. Then we share a lot of information. It's down to individual organizations. Even CNI wants to take use of that, and they have broader sort of public knowledge engagement, if you like. That's what I would um, refer to.
Okay, very good. Thanks, Isan. I guess maybe one more that David is asking here, which is, what's preventing me from snooping on V2X traffic with my own OBU or impersonating other vehicles?
Yeah, there's nothing we can kind of well, it's a very good question, and it's a big or there's a big cybersecurity on V2X generally is the hottest topic, right? We kind of secured our own environment. We're using our own certificates. There is no, I'm not aware of specific sort of publicity of those data to become available at this stage. But there are tests going on. Formal test happens on a regular basis that I would defer to that. The SMLL itself, I'm not aware of any publicizing the data.
Okay, thanks, Isan, for answering those questions. Thanks, folks, for asking those questions. I think, Isan, we probably need to have you progress here a little bit more
Yeah,
in the
well,
interest of time.
yeah, of course. No, absolutely. No, thanks for the questions. If there are more, don't be shy. Just ask questions. I may not know the answer I may not have answer to all of them, but we'll come on to that. There's another area that intelligent edge is. I'm quite intrigued that people are having an interest on the CV2X, or V2X, I should say. Generally, another use case which is a speed advisory for the vehicle approaching into the traffic light. We got signal phasing and timing, and we can advise the road users what's the optimized speed such that they can either better off stop behind a red light, or just going at optimized speed such that they can kind of avoid having a red light. Obviously, that will become really beneficial for uh, heavy vehicle in specific. Obviously, they don't need to slam the brake or accelerate too harsh, because if they know at what speed they go, they can pass a green light. That's a great example that how digitization can enable with efficiencies, improve the flow of the traffic and improving the safety of the roads. Um, this is very much talking about what outcome we're looking to achieve, is about roadway safety, turn a vehicle into a sensor. Traffic flow optimization, traffic signal prioritization is something, it's not within scope just yet, but other places in Europe that I'm aware that actually they deployed it. So what it means is if there is an emergency vehicle, then they can turn the traffic, then it can broadcast the messages to say, I'm an emergency vehicle, and I need to, get to my destination as quickly as I can, and then the traffic light phasing could be changed in their favor. Obviously, there's a huge benefit, as you can see, could be realized by simply using the technology that is available today in the market. Vulnerable road user detection is another item that we're looking for great deal of investment, which is an interesting one. Obviously, if there's a vehicle stationary because of it's broken down, or pedestrians are on the road where they shouldn't be, we know these things do happen, and we need to kind of be aware of them. And this is an area that we're looking to exploit as to how best we can kind of use SMLL testbed as a showcase that what the art of possibilities are in a real world environment. Now let's switch the gear a little and move on to the numbers a little. The casualties, thankfully, has been reduced by 2% since 2010. Sure enough, number of road journeys has been increased massively. I don't have the numbers just yet, but that has an attribute, obviously, to enhancement of technology, digitization, and really take advantage of what of the IT, of the power of IT, if you like. Connected devices, nearly 1 billion of them in the automotive industry is a shocking number. And we know this number is just keep on growing. And what I was hoping to happen is actually regulators step in and come and answer and mandate CV2X versus DSRC, etc., such that we can move on and accelerate the deployment, whichever the direction is. We would love to hear that. The other area, obviously, is kind of would worthwhile mentioning that the DSRC technology will be available in 25% of the major cities globally. So it is something that we'll look forward for expansion and more widely adopted. Obviously, one of the benefits are, can everyone just know, if all the vehicles will have a HMI and DSRC or CV2X capabilities, we can simply get rid of all the gantries, which are going to be massive cost saving for highways. I believe they have to change them so often. And given the diversity of the messages and how you can send to the drivers, then all of a sudden you can think about, roadwork warning, red light warning, emergency vehicle warning, V2X locate, which is another area that we're looking to deploy. Unfortunately, due to the lockdown, we had a little bit of slow on actually deploying some of the tech that we wanted, but still in a roadmap to deploy fairly quickly, where we have either we do not have a good GPS signal to be able to locate a vehicle. We can use the available radio technology in order to locate the vehicle more accurately and more real-time basis, such that we can inform more accurate and more relevant data to the drivers, as well as other use cases. All of a sudden, you can start to have a think about it. Stationary vehicle ahead is another area. Obviously, if a vehicle breaks down in a highway, if the road operators would get such a message, then obviously they can shut the road or they can do something about it. So that the sooner they know, the better. We know that's a massive risk within highways, and would be good to call out. These are the things we're looking to deploy at some point. Or intersection collision warning. So these are all the road safety use cases. We can start to have a think about them. With that, we are just about on the top of the hour. What I would say, thanks for joining. Thanks for your questions so far. Please do keep in touch with us. You got our emails down on this slide. There are some website I would encourage everyone to take a look on the transportation sector from Cisco, on the government engagement, and Thales Intelligence for the folks who are interested in knowing what do we do in terms of the cybersecurity research aspect of it, which Thales Intelligence are a great resource. The very detailed analysis of the things that we do. So with that, I'm gonna pause here and take questions if there are any.
Yes, there are a couple, and I'm going to go back here just a little bit from Jonathan. We have a question that says, "Are you going to use the learning from the recent A2M2C ITS pilot to feed into your work, including the use of PKI security for roadside and roadside to vehicle security?" He has a two-part question there.
Yeah, no, absolutely. We are closely in touch with the folks. We almost, I would say, we almost start off the ground on SMLL, obviously due to obvious reasons. But as soon as we kind of are getting into evolving our solutions, sure enough, we'll have those addressed, and that's exactly the certificate is the kind of is a very hot topic and cybersecurity aspect of it.
Okay, and then just as a follow-on, he's also asking, also the services piloted that includes some of the use cases that we were discussing on the slides earlier.
Correct. Yes. Some of them are about to be trialed. What I can think about, which I'm hoping to be able to do in the not too distance of a future, is a SPAT data to be broadcasted into the air, and then there's a few application that we're looking to exploit and deploy them.
Okay, and we've got another question here from Saket. Will Cisco be investigating critical GNSS signals, in particular SBAS corrections, for accurate positioning of CAVs?
This would this would be a good question for TRL, I would suggest. We kind of our approach, we have two GPS sources on the vehicle, on the test vehicle that we got, but I think I mentioned that this V2X locate is something that we are trialing it in two different locations, which means we're no longer relying on GPS signals at all, or not at all, mean for positioning of the vehicle. So the accuracy is far higher, but we generally be fusing multiple data together to locate where the vehicle is.
Okay, and he did have kind of a second comment around that. It says, I take it that in the EU and in the USA, there are only a few handful of standards which determine safety and security of GNSS signals.
Yeah, I don't have a comment on that very specific, I'm afraid.
Okay, good. I think, oh, it looks like we've got another question in from Theo. Assuming the slide titled IT to OT represents a roadmap, are there any timelines attached? So that was slide number 5, I think, was it? No.
We believe this is a journey and evolution of merging of these technology. I don't think these things are going to happen just over time. The regulator is involved. There are what I would call it mainly how to say a technology become mainstream, and SMLL is one of them. Obviously, is what we're leading on. we have heavy focus on to accelerate the digitization.
Okay, so no specific timelines at the minute.
Like I said, it's a journey. I don't envisage to say, yeah, we're going to achieve that. I defer this to project managers in terms of what's in the pipeline for today, what's about to be delivered to be SMLL specific. But that's what I would.
Okay. And I've got another from Socket. I take it that you may be using RTK for GNSS corrections in addition to the onboard GPS. Any comments on that? Do you know?
I don't have specific comments on that. No, I don't have. I need to get back to you. If you email us, then we'll get back to you.
Okay. All right. That's it for the questions at the moment. Isan, I think we can bring things to a close now.
Okay. Thank you. Thanks everyone for joining, for your time and the questions. We look forward to hear from you. Thank you. Thanks, Greg.
All right. Thanks. Thank you, Isan. Thanks everyone out in the audience for attending today.
Thank you. Bye-bye.